again with another resting. Resting is a language I'm learning today. I've learned how to print to the console, which is, I think, doing this. Hello, rest peeps. And you have to put a semicolon, just like that. You don't have to return anything, which is good. Now you save it. You save the program, you know what I'm saying? After saving, you can run it by doing some terminal magic. So the terminal magic is over here. I think I can use this terminal. Doesn't work sometimes. Let's see if we could use rest. Can we use rest C? Oh, we actually can. Okay, great. So I'm gonna do rest C and then main, actually nope, rest1.rc. So this is gonna build, it's gonna compile the rest file, and then it would bring out an exe file that I can use. So you can see here we got a exe file, which is an executable file that we have to run, so to like get our result. You can see that I actually called the rest C and then I give it the file to like compile the data, but it didn't print anything. That's because it actually creates this executable file that you can run, and then you will see the output. So if I wanted to see the output, this is what I have to do. I think it's the same file name, rest.exe, and there we go, like that. Hello, rest peeps. That's what I'm talking about. So yeah, we know how to print. That's the first thing. Now I want to learn how to create variables. Let's see, how do we do that? Okay. Let's see, do we have cargo running? Oh, we actually do. Okay, that's good. So I think using the cargo is how it allows you to create a Rust project. So we can do cargo new Rust, I'll call it Rust 1, you know, day 1, learning Rust. Ooh. Oh, look at that, we have a folder, cd Rust 1. Oh, so in the source is where we have the code file. So let's see. So this is the folder, and you can see it's got this new code for us. Save, I guess. It's got a new file for us that we can write code into. Addition, version, and name dependency. So now we're gonna learn how to run this current project that we have. Oh wow, okay. So instead of using Rust C to like compile the file this time, we're actually gonna be using the cargo build to do that. So cargo build. Let's take a look at the output. Okay. I mean, I do see new things. I see lock. Was this here before? Probably. Target. I'm not sure if target was here. I can't remember seeing target. Yeah, right here you can see I went into it and it only had 2 files. So target is I think the folder that I just created when I called the cargo build command. Debug. So there's a debug and cache dir tag in there. What about a source? It's the same thing. Oh really? Oh, it's in the debug, I think. Debug build. Oh, there we go. It's right here. This is the file that we're looking for in the debug. So we need to go. We need to do dot target debug. So this is how we're gonna run. It's basically the same thing. So I could do rust1.exe and we're done. There we go. Okay. So yeah, I guess it's better, way better than using Rust C maybe. But it is doing the same thing just by using the Rust C as well. I think this is more for like development. If you're working with like team members and stuff like that, then you would use the cargo build because it handles almost every other stuff that is related to working with team members. Okay. So to build it seems like to build the cargo, you actually have to be inside of that cargo folder that you created by using cargo build. That will create this new folder that has the Rust file and everything that you need. And then to build the folder itself, you have to go to the folder that was created and then call cargo. Wait, what was it? Cargo build. Cargo new is how you create the folder, and then cargo build is how you build it, which gives you the target folder, and then inside there's the debug, which has the exe file, the executable file that you want to run. Okay, it's good to know, good to know. Oh. Okay, so I learned about another new command that is useful, which is called cargo run. So if we try cargo run, okay, you can see this actually, I think it builds the whole thing and then it runs it. So you don't have to always go to the exe executable file and then run it yourself. You can just call cargo run, which seems to actually handle everything for you. That's actually really useful. Okay, I like that. Let's go. Finish dev profile unoptimized plus debug info. And then you can see here it just prints hello world. Okay, so I think there's also something called cargo check, which seems to like I think it's just like a way to check for errors or anything like that, before building it or something like that. So you don't have to always build it to just check for errors. You could call the cargo check function, which seems to command, which seems to do that for you. So for example, if I do cargo check, see what we get. We don't get anything. We just get check in and then finished. That's it. No. Seems like cargo check is actually very useful because it doesn't really compile the code. It's that it's trying to check if there's an error. It actually just, I think it just does it just by reading the file, reading your code or something like that, and looking for like errors and stuff. Hmm. Hmm. Not sure if this is going to be useful for you guys, but there's also a way to format like your code, I guess, using the Rust command, which is called Rust FMT, and then you give it the file that you want to format. I mean, it's useful, I guess. If you have like Rust code that is jungled up, combined and stuff like that, and it's hard to read, you can always do. So we do Rust FMT, and then here we have to give it the file. So for example, I'm working with the Rust one, so that means I have to go to target. After that I have to go to actually I have to go to, so I'm in there, so I have to go to source and then main.rs, and there you go. Look at that. Now this is what we get. I'm not sure so it was like this and it modified it to, here we go, 3 2 1. Look at that. Hey, that is so good. It's actually quick as well. Alright, now let's learn about coding. Here we go. Coding in Rust. So that was just a couple things that we need to know about working with Rust. So we're gonna be doing some very simple coding in Rust because, like I said, I've never programmed in Rust before. This is like my first time, I guess. So we're gonna be learning this together for 99 days. Yeah, I want to see what else I can build with this. You know what I'm saying? With Rust, in this 99 days that we have together. Okay, so now we're going to learn about making a variable. Seems like you can use the let keyword, and then you can assign values to it. So this is how you create variables, almost like JavaScript. So JavaScript also uses the keyword let to create variables, and there's also var as well. That's interesting. So by default, it seems like Rust will automatically decide the type of the data, so it will do that for us automatically. But there's also a way to like give it different types if you want to. So if you want it to be a string or something like that, Rust actually allows you to do that, which is really good. I would prefer like not setting types because it's a bit, really weird. But yeah, for example, if you wanted to give it a different type, I think you have to use the semicolons to do that. So let's see, how do you do that? So for example, I could do val u, then I could do this, which is gonna be str, so that will make it a string. Here I could do hello. Now we're done. So that is the string. So let's actually test if this works, just to make sure. Print line value and data, just to see if this works. Alright, now let's go ahead and do cargo run. Oh, okay. Mine did not work. Okay, interesting. Oh, okay. Did I break something? Well, you have to tell it it's a reference. You have to do this? No fucking way. Okay, so interestingly, I don't know why you have to do this. And this one is giving me some error because of the way that I'm printing this. I guess you have to use like the format here. So let's say value is value, and then data is data. See what that does. Hey, look at that. Okay, so we get hello for value, and then we get data 10. We get 10 for data. This part kind of fucks with me. I don't know what's going on here. But yeah, this seems to be working as well. So, but it also seems that if you wanted to make this work, you can do that by adding a comma after the print, the string format. So you don't explicitly have to have it inside. You can also put them outside just by doing this. So if I put value here, then data here, it will work the same way, I think. So you can say same thing. Kind of cool. And it also seems that by default, the let variables that you create are immutable. So that means they cannot change. You cannot modify them once they have that value. So by default, they're always constants. I think a const variable, mutable. Mute. So if you wanted to, for example, let's say I wanted to change this variable to something else, like 20, and then I save, then I run, and there you can see we're getting this error: cannot assign twice to immutable variable. So that is telling me you can't change this variable. What if I want to change this variable? Can I change the string variable to 20? It's also the same thing with the string variable. So I think by default every variable probably is immutable, or every variable that is created using the let keyword will always be immutable, maybe. But you can, it seems like you can also tell it that this variable can change its value by doing let mute and then the variable. So right here, if I wanted this to work, I could just do let mute, and then bam, look at that. Now we get 20 for value and 10 for data. Cool. So yeah, if you wanted to change it, you can always just add the mute after the let keyword, and that would allow you to change the variable. So yeah, very cool. I like it. I actually did not notice about the unused assignment, overwritten before being read. Maybe it is overwritten before being read. Generated one warning. So this warning is because we're assigning the value here, and we're changing the value without that value being used. I guess that's why it's giving us this warning. Yeah. So it's not really a problem, it's just a warning that tells you this is stupid. Oh. Interesting. And also it seems like when you have a mutable variable and that variable never gets modified, you do get a warning, but not an error, it's just a warning. Interesting. I didn't know you could do that. And it seems like in Rust you can also redefine variables. So just like that. This seems to be working fine for some reason. I didn't expect it, but this is actually valid code. And it doesn't even give you a warning, which is interesting. Let's go ahead and remove that. And now if we run the code again, okay, we do get a warning, which says let 10 prefix with an underscore data. There is a warning, but it's saying that it's okay. So you can see here we get data 20, and then the first one was data 10, but the new one is data 20. That's because it overwrote the previous variable that we created. I thought that was going to create an error because by default the variable is immutable, so I don't know how it's doing this. But it seems like it's working. What the fuck? Very good. That's how you create variables in Rust, it seems like. Okay. I'm not sure. I haven't really thought about this, like creating scopes in other programming languages like C++ and all that. But it seems like you could create new scopes just by using, this curly brackets here. They actually create scopes where you could like have different. You could have variables that have the same name, but they don't refer to the same variables that are outside of its current scope. So I can have another variable data here. Let's say this is 100. This data will not overwrite this data here because this is a new variable inside of a new scope. And over here I could create another variable, call it data as well, give it 200. This one will also be the same. It will just have the value 200, this will have the value 100, and this will have the value 10, because they are they're in their own scopes, and it's creating that variable. It's not like overriding it because it doesn't exist in this scope, so it just creates a new one. And the way it does that, the way it knows to create a new variable, it's actually because of this here, this keyword let. It's telling the compiler that it is creating a new variable in this current scope, and the compiler has to figure out what scope it's currently at that it's trying to create this variable. And if it decides if it, if it finds the scope, it will go ahead and run that code in that current scope. So instead of saying, okay, let's just go all the way to the top and then create that variable, it's not going to do that. It's going to stay in that scope and create that variable there, because of how how the scoping stuff works. This is makes sense. You know what I'm saying? But yeah, that's how you create scopes, and you could have multiple variables with the same name but in a different scope. They can be in the same scope. I mean, it seems like Rust doesn't really care about that. Even if you're in the same scope, you could redefine the variables by just giving it the same name by using the key let, and it will allow you to actually modify or redefine that variable in that same scope. But I think other programming languages don't allow that. Like I'm not sure if C++ allows it. I think it does, but only if it's a constant. So if you create a constant variable and you try to override it with a new variable, it's probably not going to work. I haven't tried it though, but I'm sure that's what's going to happen because it's a constant variable, so just wouldn't make sense to be able to override it. No. You're in a different scope, so it just does. No. I like this. Let me go back in here because so let's try this again. Cargo run. There we go. We get data 10. Nice. Alright. Now let's work with constant. This is almost as mutable, a mutable variable, but it will probably not allow you to redefine or or override the variable, I guess. That's the difference between it. It doesn't make sense why they do this, but yeah, it's just weird. Breaks a lot of things. So let's learn how to create constant. It's almost like every other languages, every other programming languages, like JavaScript, and so on. So yeah, we use this keyword const, and then we can add, I guess. So yeah, I think after the keyword you just give it a name. So for example, it could be any name you want. AAA, let's give it 1. And now if we take a look at AAA, see if that works. Okay, actually it did not work. It's saying, oh yeah, because it's an integer. Are you allowed? I think you actually are supposed to like tell it what kind of int, what kind of type this is, I guess. Oh great, I just closed my fucking program. Desktop Rust 79 Rust 1 clear cargo run. Let's see if this works. Okay, so I did get the output. You can see here it says AAA is 1, and we also get a warning that says convert the identifier to uppercase. So this is not really an error, it's just it just tells you that, I guess it's like it depends on your preference, you know. If you want it lowercase, you can do that. If you want it uppercase, but yeah, that works. That is a constant variable. So I think with a constant variable, it actually does not allow you to override it. So for example, let's say that I want to override this to 100 instead of being 1. Save the code, and now let's run it. I'm gonna go ahead and clear everything first, and then I'm gonna run. There, so you can see this is telling me refutable pattern in local binding. Okay, interesting. It's saying AAA not covered. Missing pattern are not allowed because AAA is interpreted as a constant pattern, not a new variable. Help introduce a variable instead. So it's giving us a new name version. For example, it's saying you cannot create this variable because it's a constant variable. So yeah, I guess that's what constant variables are good for, you know. If you want to have a variable that is not going to be overwritten, it's the best option is to like define it as a const, and that will work, you know. So yeah, it also seems like whenever you create a constant variable, you have to always give it a type. And if you leave it blank, it will also throw an error because constant has to have a value by default. It works good. Constants are very cool. Oh yeah, and also you can let's say that you wanted to create, instead of using the let, let's say you wanted to use const and then create a again, just like this, but let's give it a different type this time. Let's do like 32, and let's give it 10. So now this is also created using the const function to recreate the variable. This is also going to give us the same error. Basically, it's the same thing. Once a const variable is created, it can never be, you know, overwritten or reassigned, basically. Constant are I think are very useful for like a lot of stuff. You can use them for like you know, values that should stay the same all the time, you know, in your program, and you don't want them to be changed. Like birthday, for example, or the month the month of the birth, the day of the birth. Um, mm, all right, let's learn about other types that we have. So there's integer, strings. I think there's also characters as well. So if I wanted to create a number, I can do that by doing this and then say 32. This one is going to create a number variable, which means this will always be a number. And then if I want to create a string, you could do that by doing v equal I32. I mean, reference string, it seems like. I32 is the default value for like a number. I think there's also other types. Oh, there's also I8 and I16 as well. Oh, okay, so there's a lot of number types if you wanted to work with them. So there's that. This is I do comments. There's I30, I8. There's where's the I? Can't find it. There we go. There's I16. There is I32, which is the one that we have, I32. Then there's I64, and then I28 is the other one. I think there's also other types of numbers. So there's unsigned integer, which is you instead of using the I, you replace it with the U keyword. It's probably more as well. So these are like numbers and signed. So unsigned integer, which is the U, it means the number value cannot be a minus, cannot be less than 0. If it's less than 0, that's probably gonna throw an error. That's what the U is for. It's for unsigned, I think. Unsigned integer. With the I integer type, you can actually use the negative numbers. So there's that. Hmm. Okay. Now you can also work with floating points as well. It seems like. Ooh. So there's two types of ways that you can use the floating point. So let's say you wanted to do that. You can do that by using the F and then the numbers 32 and 64, I think. So for single precision, I think you would use a 30 32, and for a, let's say, double precision, you would use 64. So that would be F and then the number 32 for single precision. Let's say it's like, something like that. I think you can put F here, no? Okay, I think it just decides from there. And yeah, it's basically it, really. F64, which is for double precision, I think. Hmm. Yeah, those are the only types that you can use with floating points, the F32 and F64. There's also Boolean types as well. So if I wanted to do let is active, for example. So here we could just do bool, I guess. And then we could do 1, 2, 3, true. So this is going to be true or false. And it's also possible, because the value by default, the value of this boolean is the 1 or 0. So it can also be represented as a number if you wanted that to. And by default, you don't really have to give it a type. If you're using the like keyword, it's going to decide the type for you. But if you wanted to add the type, it would be this right here: colon mark, semicolon, colon, and then the type bool. Ooh, yes, now it's the character, where you could like have one character in a variable. Basically, that's what character is. I think it's just char. So you could do let's say let first let's say, what should we call it? Say gender, let gender, and then we're going to do char. Char is the type of the type, which is for character. So you have to use single quotation marks for characters. So right here, I can put like, let's say, M for male. So yeah, that's what character is. It's basically a data that has only one character, starting from It can be, I think it can be anything. It could be like any letter starting from A up to Z and from 1 up to 0, something like that. So you can't do like, let's say 10. This is not gonna work, I think. It has to be from 1 up to 9 or 0 or A, Z, you know, B. You can't have like 2 letters in there, 2 characters. So like a minus works and equal works, semicolon works because it's a character. This works, anything that is by itself, I guess. So like 99 doesn't work. X works, you know. FM does not work because it's 2 characters. But yeah, very cool. Those are the only things that it accepts just a single character. There is also a string as well. So with a string, it will allow you to have like, you know, main, for example, gender, or let's do like other gender, and this would be a string equal male. There we go. So this would be a string. This is going to tell it that I am a string, I guess, you know. And that's why I'm using double quotation marks, because we are writing a word or whatever that we need to write, really. And we're using the str with a ampersand to represent a string. I think it's just saying a reference. Alright, so we can create tuples, which are okay, so this here will create a tuple. Well, a tuple, I think, is like some almost like an array, but it's just that it's immutable, meaning you cannot change it or modify anything inside of it. And the type, the way you would create the type of it is based on the same thing like this. So here we're saying it should have a 10 value, it should have 10, it should have a true, and it should have an 8 letter. So that, if you wanted to represent that, you would do the same thing, opening and closing parentheses. Inside this, you would put the type of those data. So this would be a boolean, and it will be a, actually no, this would be an integer, so that's going to be like, let's say I32, and then this would be a boolean, and then this would be a character, just like that. That is how you can create the type. And you don't really have to. You can always just let the interpreter or the compiler handle that for you by using that key let. It will go ahead and handle the type. Let's say that we use what we have here. So we can put number, then we can put active. We can also put the gender that we have, which is a character. So this is also the same thing as before, but we are telling, you know, we're just specifying the type here. And you can see, like, something like this, you would normally not do this. You would just let the compiler figure that out by itself, because by default, sometimes, let's say that the variable is like a global variable created somewhere else, you won't really know the type of it, so it's better to always let the compiler handle that for you. but because I know the types, it's right here. I can see them. That's why I'm putting it here. And also because this is the best way to also learn as well. So yeah, it seems like it's by default mutable, immutable, but if you wanted to modify it, it's just the same thing. Like basically all the variables here that I created are immutable, meaning they cannot be modified. But if you add the key mut or mut, it will allow you to modify it. Even a tuple for some reason. I thought tuples were, not mutable. Like should not be able to modify it because it doesn't make sense, right? To like modify a tuple. But now let's learn how to get the data from the tuple if we wanted to. So we can say print line so interesting. It seems like the way you would access the data inside of a tuple is by using a dot notation and then an index notation. So it's almost like an array, but it's just weird the way it looks. You're not using square brackets. You're just using a dot and then the index, the position of that value that you're trying to access. So like I said, it's just like an array. So it's starting at 0, which means it's the first element inside of the tuple. And if you want to get to the second one, you would put 1 because 0, 1, and then 2, which would refer back to the third element. So this looks very ugly. I'm not gonna lie, I hate the way this looks. I'm sure there's another way to also access the data from a tuple, not just one way. So let's go ahead and output the data here. So I'm gonna do that, and then I'm gonna do t.0, then of course because we have 3 items here, I'm gonna just gonna do this here real quick. t.1 and then t.2, which is the third element. Alright, save that, and now let's see what we get. Okay, so you can see here I'm actually getting the exact output that I need. You can see we get 1, we get a dash, and then we get a boolean value true, and then we get n, which is the correct data. Okay, I'm getting a warning for some reason here. Did I break something? Unused variable. Okay, interesting. If this is intentional, prefix it with underscore with an underscore to tell it something, I guess. Okay, interesting. But yeah, that's interesting. That's how you access the data from a tuple. So you can also modify tuples, like I said, if you add the mutable keyword. So if you put the mute function here and you wanted to modify it, you can do that by, it's the same way as you're accessing them. This is how you access it. And if you wanted to modify it, you will also refer back to the same indexing and then change the value. So for example, I could change this to 100. So previously it was 1, so now if I save it and then I reload the code, we'll see we get an error. Great, I forgot to add a semicolon. Oh my god, why did I close it? I always forget. Cd into desk, rust 999, and we need to go to rust 1. Oh great, why did that not work? Did that break something? That should work. Okay, there we go. Alright, let's do cargo run. There we go. Alright, now you can see we get 100 instead of getting the value 1. That is because we modified it right here. So you can modify it, but if I remove this mute function, now let's see what we get. Look at that, now we get this warning, we get this error here, cannot assign to top.0 has t is not declared as mutable. So for that to work, we add the mute keyword. It's very cool. It's simple, and that's and one more thing as well is that you cannot add extra elements. So for example, if I wanted to add like let's say I don't know, let's say other gender, this is the other string, which is right here, male. If I wanted to add that, it will not allow me because this only expects 3 parameters, and now I've given it 4 parameters. So for this to work, I would have to also say string, and then it should work. So if I go ahead and put t.3, that's going to be the other value that I have, and we get an error. Great. Unused variable price. Okay, what's the error? Let me see. What is it saying? Rust. It's saying Rust generated could not compile. Oh, okay. It's not clearing everything. That's great. I'm just going to clear the data here. Okay, now it's saying never used. Third, okay, never used. Oh, I forgot to add the fucking bracket here, so you could take that value. Okay, now let's try again. There we go. Okay, so now you can see we get 1 true M and then male. But if we take this string out, that extra parameter from there, and run this again, we don't get exactly the value that we want, because it's expecting 3 argument, and we're giving it, and it's expecting 3 parameter, and we're giving it 4 argument to the creation of the tuple. Nice. So that is tuples. Let's try arrays now. Let's learn about arrays. So how do you create them? I think it's just a list. No, it's not array. Interesting. So this is how you create arrays. Arrays are also immutable because we're using the let keyword, which makes them immutable by default. It basically makes every variable immutable, meaning you cannot change it. So if you wanted to access data, it's almost the same thing as any other programming languages like JavaScript, C++, and all that other shit. So you could do, if you wanted to access the data, you could access starting from 0 by using the bracket. 0 representing the first element in the array, 1 representing the second, 2 representing the third element in the array, and so on. I think arrays are like tuples, but on steroid. What? How do you say that word? Steroid, something like that. That's what arrays are. They're basically a version of a tuple that is way more, better and widely used from every other language uses it. Tuples, I haven't really seen tuples in like a lot of languages. Like the only places I've seen it is in Python. That's it. I think maybe C++ also uses tuple, but it doesn't really use them the way as Python does, or even like the way this language does, Rust, the way Rust does as well. It's way different, I think. It's like it has the same concept, but just a bit weird, and it's not the same. But yeah, this is how you create array, but oh, you actually have to use the bracket. I thought you can use like the keyword array itself, but actually, if you wanted to create this with, I guess the type, you have to use this. It seems like it's the same thing as the tuple. You use the square bracket, just the same way you created the array, and then in here you give it the type. So int 32, int 32, and so on until you reach the maximum values, or values that you want. So here there's 4, so that's why I'm putting 4 here. And if you had more than 4, then you'd put that many. That's why it's better to just let this compiler handle that for you. Oh, you actually have to use a semicolon in this case. Oh, well, you could do this, or if you wanted to tell it you have a lot of them, you just do 32 and then the number of the data inside of here. So I have like 4 of them, so I just put 4, and that will create an array with 4 recurrent array size 4 with the same type of 32, I32. That's what this does by adding this semicolon, it seems like. So I guess we could do the same thing on this part as well. So because I have 3, if the types are all the same, then you can use this kind of format. Mm. And it seems like you can also, when you create the array, you actually have to give it value, basically. So right here, I'm giving it an array of 4 items that are numbers. If I happen to like remove this, right, and run it without giving it anything, it will throw an error. So you gotta watch out for that. This is a bit strict, very restrictive, I think. Okay. That was good. Alright, so this is how you work with that. Now let's do something about, instead of deleting this, I'm actually going to comment everything out. Things that I learned, just keeping them here. So that would be, if you wanted to access data, like I said, you basically do something like this. 1 array 2 and then array 3, and we're done. Okay, so now we're just gonna learn how to get input from user, I guess, so you could do that by including, I think, a library that would allow the user to ask for input from the user. Let's see how we do that. IO, so we could do use import, oh no, use std IO. So this will give us the library that we can use, like the ask for user input, I guess, by using the IO library. We're using this use function. I think this makes it so it's globally accessible, without having to refer back to std. Okay, so we're gonna create a variable that will get the user input. Get user input. So that would be string new. So this is creating a string that we can use. This string colon colon new will create a new string, an empty string variable that we can assign values to it. I guess we can assign, like, you know, some stuff to it. And I called it mine get user input because it's going to collect the user input. So we can use IO stood in. So stood in, it's the function that we need to use. So we call this to like tell the user we're asking for input, I guess, something like that. It's stood in. So with this function, we can call read function, or read line mute, and then the variable that we created, in this case, is called user input. So this is going to create a mutable reference to the variable that we have, which is right here, telling it that this is a mutable reference variable that we can modify. Well, mostly it's saying, it's giving it a reference, so we could, like, whatever input the user gives it, it will assign it to that variable. That's what this is doing. So the reason why we're doing this, the reason why we added this here, is to tell the function that we're calling that this whatever change or whatever result you get back, you should send it, or you should assign it to this variable. Now, if we don't give it a mutable reference, the data that we're going to be sending will just be a copy of what this data is. So it will be like, it will be just a copy variable, basically. Any changes that happens to this variable will not be affecting the outside or the main target that we're trying to work with, the main variable. So that's why we're using reference mutable. So, and also, this is how you actually send a reference, just by using the ampersand. But if you wanted to also modify it, you have to add the mute after the ampersand, which tells it that this is a mutable reference, meaning it could be modified as well. Interesting. So that will give us the user input, I think, which means we can then output that to the console. So, see. Actually, we also have a expect. So this is like when the user, I guess, cancels the request or something like that, or the input doesn't is not supported, I guess, in the computer. It will have a fallback, which is like an error. It will raise an error or something, or throw a message to the console letting the user know something went wrong. That's what this expect is. So here we can say error or no input was or error reading input, something like that, right? Error reading input, and we're done. So that will be like an error message that we can use. Now that we have that, we can go ahead and print to the console. Enter here we said you entered, and then we give the input here, the data here, and then we can go ahead and say print line, enter text. So yeah, that's it, I think. Let's try this. Oh, okay. That didn't work. I think I broke something. Enter text, and then what did I do? Print line. Oh, I forgot to add the exclamation point. Okay. Let's try that again. There we go. So you can see here it says enter text. So I'm going to say hello. And there it says you entered hello. Easy. That was good. Now there's a new line though. I don't know why. I think it's because print line, which always adds a new line whenever I call it. So that's how you, seems like that's how you ask for user input. So I'm just going to put a comment, ask for user input. Just do that. Let's put like a type here. What this is doing. This is creating variables. Let's say variables and types. Variables and types. Alright, let's go. And yeah, so to ask for user input, it seems like we gotta use the library IO from the standard library. That library gives us the function called standard or stdin, which is a function that we call, and then it gives us back I guess like an object that has other member or methods that we could call functions. In this case here we're calling a read line, which is, I think this reads like one line. So if you happen to press a new line, the enter key, it would stop, like it would move onto it would stop the read line function and return the result. That's what read line does. Kind of cool. So I wonder, can you also do, instead of doing this, is it possible to just do empty string, right? And then making this a string, so without just having to call the new function. I think it's possible, right? Nope. Okay, you cannot do that. Read line. So I found a reference of that string, but I expect it to be a string object, which we get that from calling the string new function. Okay, so that's why it's not working. Whoops. Okay. So that is how you ask for user input. Let's go. Yeah, boy. Okay. So you ate, I ate, and all that shit. Okay, so we get the user input and then we trim the data with a string. It seems like you called a trim function. Let's say you wanted to get like the user's age or whatever, right? It's actually easy. So let's do that. Then we're gonna do we're going to ask for user input, user data now. So we need to do, let's say we ask for name, enter name, right? Then we can say hello, put the name, right? And then we can ask for age, for example. So we could take the same thing here, put on the bottom here again, then ask for enter age, and that would use the same variable. It's just going to override it. Now that we get the age, we can go ahead and do something with it, right? Let's just, for this example, we're just gonna print it again, I guess. You can put like more information now, so I can say name, then put the name, I could do comma, age, and then put the age. So, oh, this is actually going to be hard because name is over here and we're modifying it. So we need to have two different inputs here to like represent this. So this one is getting user input. Say we create two of them. We're going to say get user name, and then here we can say get user age. So for this is going to be the name, and this one's going to be the user age right here. That's the user age, this is the user name. It's going to print that to the console. Actually, instead of printing it, we're just going to ask the user for that. And now we can print it to the console. So, but because we're asking for user age here, we need to convert this to an integer. So that would be alright, so to convert user input into integer, it seems like we have to let's say we call it edge, give it I62 64, and then we say get user input dot trim dot parse, and then unwrap. This is for like handling stuff. So the trim function will remove like any new lines or spaces, and then the parse function will convert the input, I think the string, into an integer, and then the unwrap will probably return it back. I think that's how it works. So we can say unwrap, and that's it. Now we have edges. Also, I didn't have to convert this to an integer. I'm doing that just to practice, basically, you know. Just to keep in mind that you can convert input to integers. Sometimes this is like an important, something that you will have to do a lot. I think if you're working with the user input, you might need to ask them for like, you know, credit card number or their birthday and stuff like that. So, you know, you would have to convert those values into integer to like work with them. And then right here we're gonna go ahead and put age, and we're done. Let's see if this works. Alright. I guess I could say, you can see here it says enter name. Let's make it big so we can see the text. So I can see here it says enter name. I'm gonna go and go Xiao, and then it says enter age. Let's go 24, and there, nice. It's got a new line here for some reason, but you can see it's got the name and it's got the age, and it didn't really throw an error, so that's good. That's good progress. Very good progress. And it seems like the unwrap function takes the integer and parses the value, I guess, and it checks if this is a valid integer, and then it returns it. If it's not a valid integer, it will throw an error, crashing the whole program. Probably not a good idea to use the unwrap function, because users sometimes could also input like invalid character. So it's I'm sure there's a way to like handle this kind of problem. Okay. Let's learn about conditions. I actually have not learned about that yet, you know. I've only learned about how to create variables and types, arrays, tuples, user input, and stuff like that. So now we're gonna learn about the if statement, the conditions and in Rust. So yeah, here we go. Conditions. So the logical operators are the same as every other languages, programming languages. There is the less, the equal, the less or equal, the greater than or equal, and the not, and then the equal, the equality, I guess, comparison. So this one's saying if it's not the same, and this one says if it's the same. This one says if it's greater or is the same, and this one says if it's less or is the same. Normally you'd only use the less than or greater than or equal, the less than or greater than operators when you're working with like numbers or something like that. This when you would normally use this kind of operations, but this two could be used with any other type. So it could be used with like string format, strings, characters, booleans, any kind of object. I think you can also compare two objects together. So if you have a referenced object, and if you compare those two together, it would probably say they're the same. No, it would not say they're the same, but they are pointing to the same thing. Maybe it might say they're the same. I'm not sure. Not sure how it works on that side, because some programming languages don't say that they're the same. So let's say you had a variable a that points to variable c, right? And variable c is equal to 100. And then we have variable b pointing to variable c as well. And if I compare A is equal B, some other languages might return true because they are pointing to the same variable that they're referencing to, but some of them would say they're not pointing to the same variable reference. But if I was to say B is equal A, then this would return true as well for some other languages. And if I was to do B is equals pointing to C and A also pointing to C, and do the comparison here, like I say, some other languages would return true, some of them would return false. I'm not sure what Rust does though, so yeah. There's also logical operators. Those are the %, double and percent to represent an and then there's the or to represent like the what is it? The or, and then there's the exclamation point to represent not. So these are the logical expression that you can use for like combining things or also separating things as well. Conditions. Okay, so yeah, let's do some if statements now. So that would be like data, let's say 10. And then we could do if, let's say data, if data is less than or equal to 5. So this one is going to compare, this is going to do a comparison, checking if the data is less than or equal to 5. So the way this will work is it will get the value of the data, and then it will check the value of the data, compare it with this value here on the right side. If they're the same, this scope will get executed. This block of if statement will get executed. So any code that I write here, let's say I do print line, the data is 5, for example. That's the output that it's going to print. So if I run the code, we're not going to get any output. So you can see here we have a warning, but we're not getting output. That's because data is 10. So if you wanted to, let's say, catch this statement because it doesn't pass, there's a way to also catch it. You could use the else and then add another block. So over here, we're going to go ahead and add another print function. Let's say the data is not 5. Okay, let's say the data is not 5. Now if I save the code, I run again, we get this output which says the data is not 5. That's because the data is set to 10, and that's why this block on the bottom here is the one that gets executed instead of this block right here, because the comparison expression that we have is failing, so it causes it to move down a little bit. It moved to the next condition statement. Now let's say that we change the data to the actual value, like 10. This is going to say the data is 5 because that is what the text is. So you can see here we get the data is 5, but the actual data is actually 10. If we wanted to make this be the same value, we could just do something like this, and there we go. Now we get the data is 10. So yeah, let's say we wanted to only do this if the data is greater than 10. If we wanted to do that, that would execute this one. The statement condition failed. Then here we give the statement condition, let's say executed. Right now, if I run the code, we get the statement condition failed because of the way we're doing the comparison here. We're saying if the data is greater than 10, it's not greater than 10, the data is equal to 10. So if we wanted to check if it's equal to 10, then this is what we have to use. So we just do equal, double equal signs, and now we get the statement condition executed. So that will do whatever it's supposed to do. There's also the not logical expression operator that we can use. So here we can say the data is not 1, for example. Actually, let's say the data is not 10. I save the code, I run it, we get failed. Now if I go here, I say the data is not 1, right? And then I run the code, we get the statement executed, because, you know, it's good, you know what I'm saying? It's good. There's also another way to do this. So let's say that you only wanted this to execute if it doesn't match a couple other values. So if you wanted to do that, normally you could use an ampersand here, double ampersand, to tell it if this statement fails. Actually, I have to use the or statement. So here you can say if this statement fails, then maybe check the other one, which is going to be data is not equal, let's say 2. So here I'm going to put data is not equal 10, and then we're going to have, so if I run this code now, we should get statement condition executed. The reason why we're getting this is because it's actually executing the other condition that we have, which is comparing the data to not being the same as 2. The first one was comparing the data to not being 10, which failed, and then it said, okay, let's try the next one, which is comparing data to not being 2, which is true, so it succeeds and executes the same. Now if you wanted to do this but in a different line, you could do that by using else if, I think like this, yeah, and then you can say data is not 2 or 20. This could also work as well because it's the same thing. So right here I'm going to print something unique. I'm going to say this is a news condition block. So if I save this, reload, now we should get nothing. Okay, I forgot to put a semicolon. What is it called? Something, it's called expansion point. Okay, so you can see here we get this is a new condition block. So this block is getting executed because we have this else if. So else if is the way to like combine, I guess, conditions together. So if the first if statement fails, it goes to the next one, and if this one fails, you can also add another one if you want to. But if all of them fails, then it will go to the default one, which is the else block. The else block will always get executed if the statement fails, basically. If one of the condition, or all of the condition, not one of them, if all of them, well, if either one succeeds. So for example, if we have multiple of them and either one of the conditions is executed, it will by default fall back to the else block, which then will execute the code on the else block. That is how that works. So yeah, that is how the if statement works. It's really, really cool. Let's learn how to make function now, which is basically the same thing as using the fn. I think that's how you create a function, by the fn function. So if you wanted to create more function, you have to do the same thing. So you just do this. You just call the fn and you put it in. The reason why we're using fn because it seems like that's how you define variables. So in here, I'll convert. This is a test function block. And then if we wanted to call the function, simply you just go ahead and call it from here, really. And it's very simple. So you just call it just like normal every other programming language is there. So if I save the code, run it, we get this is a test function block. You can see this output here, which is coming from this function. If I don't call that function, let's say I just comment this line out, then I run the code again, you can see we're getting a lot of warning. It's not an error, it's just warnings complaining to us for some fucking reason. I hate that shit. But yeah, that's how you call the function and how you create it. Very cool. Oh yeah, you can also accept parameters, or get values from the function call. So for example, if you wanted to have a variable, let's say data, you can do that here, and then value, right? Something like that. Just do this and this. Now I can put data here and value here. And now when I'm calling this function, that means I have to actually provide those data. So I'm gonna give it 1 and 2 and run. Okay, we're getting a warning. That's because you're supposed to give it a type actually. So by default, it seems like you always gotta make sure you got the type here. So let's do like 32, like that. Now let's see if that works. Okay, it's actually the same thing. Okay. So it seems like all the parameters that you create will have to always have a type for some reason. And there we go. Look at that. Now we get the function output and we get 1 and 2. Nice. That's how you create parameters. So you can also return data as well. So you can do some expression, I guess. So Rust expressions, for example, that is, wait, no, this is that expression? Rust expression statement. So this is a way to somewhat create variables and do like operation inside of that variable. So this data will get whatever the last value is. So I could do like let's say v, and I could assign it to like 1, and then I could change this to being whatever I want it to be, like 10. So that's going to give us 11 by default, and you're not supposed to add it semicolon at the on the last line. If you wanted to, you can, but if you are doing something else, so like doing plus 10 and then doing plus 20. Now you can see this one doesn't have a what is it, a semicolon. That's because this would be the last value that it returns. That's the reason why. So here, if I go ahead and print this, see if it works. I'm gonna do data. I'm not sure if this is correct, but it might work. And put data here. So the value should be, let's say 11, so plus 10. We got 10 plus n, that's 31, I guess, right? So we got 31 as the main value. Let's see if we get that value back. Okay, we did not get it. I think I did something wrong. Oh, it's got to be mutable, of course. So you have to actually make this mutable, it seems like, for it to work. Okay, what did I do wrong? Oh, it's because V has to be mutable, not this one. I was like, interesting. Okay, there we go. Now you can see data is actually 31, and the reason why we had to actually make this mutable because we're actually modifying the value here. So I actually forgot about that. That's what you get. So you can also specify a type with a function call. So by using the arrow sign after the what is it called? Parenthesis from the function definition. So right here we use this arrow and then we tell it what type we're returning. So if we're returning an integer, i32, that's what we're gonna tell it to do. And we can do, data plus value. By default, this will be the return value. Or if you wanted to explicitly return, you could also use this as well, data plus value. So you don't have to always use the return statement. It seems like in Rust it knows the last expression will be the returned value. Kind of cool, I guess, But yeah, that's how you tell the Rust function what kind of data this function should return, the Rust compiler. So in this case, it's telling it to return an integer, and that is what this is. Over here as well, like I say, I'm gonna go ahead and delete that. But yeah, cool. All right, for today's learning Rust, we're gonna do we're gonna learn about references and memory allocation using heaps and stacks with the Rust. Let's do it. This returns values, so that would be something like x, I guess, right? rest stack. Hmm. So normally variables will be created. Let's say you're working with like minimal variable data values like numbers. Probably strings are also data values that get variables that will get stored in the stack as well. So like if I create let number 1, this will add it to the stack basically. Oh yeah, from hello. So the string is the one that will like be stored in the on the hip, I think. So you can, so let's say I do something like n, right? Then I do string from Xiao sings as an example. This one will create a variable on the hip that points to Xiao sings. That's what a hip is, I guess. And I think you have to also free this as well because it's being stored in the hip, right? Or does it manage it itself? So I don't think we can print this. Let's see if we can print it. Print line name. See if that works. So you can see I cannot print it. Format argument must be a string literal. Must be using string literal. Okay, let's say maybe that's why it's not working. Okay, what if I do that? This one actually works. Okay. So you don't actually have to dereference it. I thought you did. I don't think they're pointed. They're just stored at the hip. Maybe it's a different pointer. Hmm. I think it clears this up automatically. It's not like it's a pointer, you know? It's not a pointer. Maybe it is some kind of pointer, but it's not like the raw pointers in C++ that you see. Because those you actually have to clear, free them yourself. I'm not sure how Rust handles this. I think I heard something about Rust that it handles like memory management. So like it knows when, even if you have a pointer, a raw pointer, if that pointer is not being used. I think it just handles that case or something like that. Something. Can't remember. I can't exactly remember the exact words, but yeah, something like that. Okay,